What's up, people? Hello, everyone. How are you guys doing? All good, all great. What's up? Can you all see me and hear me clearly? All good? Hi, Mayank. Hi, Uday. Hi, Nishchita. Hi, Sachit. What's up, people? Menti to hai, bro. Hi, Teddy. What's up? Hi, Nishchita. What's up, guys? What's up? Hi, Mayank. Can you guys all hear me and see me now? Give me a quick yes. CBSE session nice because I'm early riser. Oh, all right, Uday. I've taken that into consideration now for sure. Let me talk to the team and see what we can do about it. Yeah. Thanks a lot, people. Long time no see. What's up? How's life? How's everyone doing? I am doing awesome. Not so awesome actually. I don't feel that great, people. I have a little bit of a cold from past 2 days. So yeah, that's pretty much it. How are you guys doing? By the way, how many of you guys are free to move about now? Like Bangalore lockdown is completely lifted now. What about your state? Like whatever state you guys are from, is it lifted or you guys are still under lockdown itself? Bangalore though is completely open now. Anyone can do anything you want. Hi Kanan, what's up? Hi Sanskriti, what's up? Thanks a lot Gopal. No, Are Anusheji, Karnataka, Abhishek. Still there in Haryana also. Arre, Karnataka Rishita. Arre, awesome. Thanks a lot. Thank you, Swati ji. Thank you, Abhi. Sorry, Abhi. Thank you. I saw your mail today. I'll reply to it. Is it Amrita? In Kerala also, is it still there, the lockdown? Punjab still? No lockdown in Tamil Nadu. Arre, Maliyuri. Pade. Punjab also lockdown. Arre, okay. This is Ruben. Oh, what's up, Ruben? How you doing? Welcome to the session. Hi, Amrita. Welcome, guys. Welcome. So, let me introduce myself first. My name is Anoop. For all those who are new, I am a physics master teacher here at Vedantu. I've been teaching for the past couple of years now. I've taught and mentored thousands of kids, maybe even 10,000 plus kids all over the country. I've helped them score 90% above in their board exams as well. So that's a little bit about me. If you want to know more about me, we'll talk to each other as we go throughout the session, and I'll also give you my email ID towards the end, and we can get in touch. And yes, for all those who are asking, I am a Mallu. How many Mallus here, by the way, people? Any Mallus? Mallu means people who are from Kerala. I was born in Kerala, but I was brought up in Bangalore. So my Malayalam is not that great, but I can still manage. But yeah, that's pretty much it. I had a very interesting life then. What about you guys? TRP is. I know. Anushriji, ki kare, what to do? Bangalore, which area? I stay near Electronic City. There's a place called as Electronic City, which I'm pretty sure if you stay in Bangalore, you would have heard. It's like the IT thing, like Infosys and Wipro and Siemens and all whatever companies are here. So I stay near that itself. Is it Aaron? Ayush, you're also like, Punjabi Bhumika ji. Teach me some Punjabi now. What is this? When will you guys teach me? I'm teaching you people. When will you teach me something? What is this? This is give and take policy, no? Anyways, so welcome to today's session, guys. This is the second session of Light, where we are going to be talking about ray diagrams of concave and convex mirrors. Now again, it's a very important topic. Before I get into the topic and start with everything, let me tell you something very exciting. So we have some pro exclusive micro courses starting from 5th of July. Now these exclusive micro courses are for people who enroll into the Vedantu Pro subscription courses, which I'll be talking about later on. But if you want to be a part of these pro exclusives, micro courses, you want to study with me or all your amazing teachers on YouTube platform, you can enroll by clicking on the link given in the description. Now I have two special topics for you guys. One is be a pro in lens bro, where you'll be talking about lenses, and secondly we'll be talking about electricity. We'll master everything that we need to know about electricity in the least amount of time possible. All right, so that's about the pro subscription courses. Again, I'll talk about it more as we go towards the end. For now, guys, I would like to start with a quote, just to entertain ourselves. The quote is this: don't say it's difficult when you have not even tried. How many of you guys have done that before? Give me a quick hands show. Yeah, no, nice. Oh, awesome, Bhumika ji, awesome. You guys have to. Every one of us, even me, sometimes we all do this. We all, before even we try something, we say that it's too difficult and we don't even try it. What I would suggest for you guys at that point of time is very simple, guys. What are you going to lose? Ask yourself this question: what are you going to do? Even if you try, even if you, let's say you're bad at it, what is it that you're going to lose? I'm sorry about the sound, I don't know what's happening, but anyways, ask yourself that question. And trust me guys, every single time the answer is not going to be that it's going to be some life-threatening situation, nothing like that. So aram se chill out, give it a shot. If it works, it works. If it doesn't work, it doesn't work. All you have to do is just give it a shot. Alright? Because fear kills more people than death itself. That's what they say. Alright? So anyways guys, let's get into the topic now. Everyone get ready for the Mentimeter now. So these are the topics that we'll be doing in the days ahead. So do not forget to subscribe to the channel, because a lot of content is coming your way. Lot of sessions are there for light. We'll be covering every single nook and corner of light. So make sure that you subscribe to the channel. So I am going to start the I think we'll start with the Mentimeter now. Quickly join by the Mentimeter, and then I'll show you the answer for the homework question as well. Alright guys, so what you have to do is this, people, all those who are new, go to www.menti.com, menti.com, and enter this code 56893579. Alright, once you're in, let me know so we can get started. Alright, it's not mixed, it's some driller. Someone is drilling somewhere, and I'm able to hear it very clearly. Yeah. Hi Kirti, what's up? What's up? Yes, I do remember you. Hi Aaron, in awesome buddy. Let me know once you guys are in. Human I will be doing it, Shashidhar, one after another. We have just started, so don't worry. We will complete all. We'll get into every single thing. Don't worry. All topics, every single chapter would be covered. That is for sure, 100%. Alright. So guys, quickly. So we have 3 questions in the start. That is from the previous session. So if you haven't watched that previous video yet, make sure that you watch that. And today we'll be doing the quiz after I teach the topic. It's not going to be that long, but it's very important, because you guys know ray diagrams carry a lot of marks. And if you understand the ray diagrams of mirrors, lenses will be super duper easy. So if you can just understand the ray diagrams of concave and convex mirrors, lenses would be pretty much exactly the same. So all you have to do is listen to today's session properly in order to understand this. Alright? Yeah, people, sounds good? Wait for 1 minute. Alright, sure. Yes, Teddy G, what's up? Yen matadbeku Nishita. Ore. Yeah, I speak Kannada. Better, yeah, we'll bet also. Why not? Join. No, you're not late. You're right on time. Just join the quiz quickly. Come on, quickly, guys, quickly. Done. What bet, Kirti? You have to tell. You guys have to give me the parameters and all. 80% and above, or 80% less, or something like that. Or do you want to be more? Do you want to make it much more tougher? You guys let me know. Hi Sanskriti, hi Nidhi, what's up now? Welcome. But call Abhi sir. Alright, if you guys win, then I'll call Abhi sir. If you guys lose, then what are you gonna give me? That is another question. Okay, so yeah guys, this is the bet. 80% above if you guys get in all of the questions. It's not just one question, all of the questions. Okay, we have 8 questions. If you guys get 80% above in 6 questions. 6 questions. Not 8 also, 6 questions. Then I'll call Abhi sir right away. Alright? 6 questions. That's 6 out of 8. That makes more sense, no? Okay, 7. No, that's 70. 80 makes sense. 80 makes sense. 70 is too easy. Alright, 6 questions. We'll call Abhi sir. Otherwise, what will you guys give me? Otherwise, just like, share, and subscribe. That's all. Okay, 5. Alright, 5 out of 8. Now, 5 out of 8, 80% above. We'll call Abhi sir in the session. Otherwise, what's up? It's cheating, right? Alright, I'm agreeing to you people now. Alright, so yeah guys, anyways, let's get started. 30 of you guys are here almost. So I'm going to start the quiz in 3, 2, 1. The first question on your screens right now, people. Go ahead and take a look at this question. What word means to bend light rays towards each other? Options: converging light, diverging the light, virtual light, or real light. What word means to bend the light rays towards each other? Quite an easy question. I'm hoping that this one's going to be more than 80%. If it's not, then good for me. Good for me. If you get it also, it's good for me. If you don't get it also, it's good for me. yeah, that's it. Alright guys, so here it is, 26 out of 30. That's All right, that's 80%. All right, so guys, anyone, someone keep a track of this one. All right, so one question out of 8. Someone has to keep a track of it. I'll forget. Someone has to keep a track of it. Who will take up that huge responsibility of remembering how many questions we got 80% and above? Anyone? Any volunteers? Any kavali kali bali kabakras? All right. Oh, okay. So that's Riddhi and Teddy. All right, your job. That's your job. Huh? I'm not remembering it. That's all. So first question, people. Congratulations. 80% above. 26 out of 30 got the right answer. Congratulations, guys. Yes, the right answer is converging light. So when you have several rays of light which are parallel to one another and you are making them meet at a point, that is called as converging the ray of light. And if it's moved away from one another, that's diverging the ray of light. Second question. Here's your leaderboard, by the way, before that. The leaderboard goes like this. Mealy is on the top. Evangela. Oh, is it? Happy birthday, Evangela. Happy birthday, guys. Wish Evangela happy birthday. Da. It's a birthday. It's happy birthday, Evangela. Take care. Da. May God bless you. May you stay happy. May you have all the things that you wish in life. Stay blessed. Da. Stay blessed. Palak, high five to you too. Love physics. Thanks a lot. Me too. Hi, Shita. What's up? Riddhi from class 9. Anushri, Nishita, surprise in microcourses. Gauri, Niranjana and Mishti Thunder. High five to you too also. Mishti Thunder _ Thunder. Alright, congratulations. That's the first question. Second question, people. Here we go. Let's go. Starting right now. Here it is. Dusra question. A ray blue passes through X, strikes a concave mirror and gets reflected back, which is drawn in pink, through X as shown. Name X. Is X the pole? Is X the radius of curvature? Is X the center of curvature? Or is it the focal point? Is it Kirti? Happy birthday in advance, Kirti ji. Happy birthday in advance. Have a party. Da. Stay safe though, stay safe. But may God bless you too, Kirti. May God bless you too. Alright, come on, people. Done. Awesome. Here we go. Oh, no. So out of 2 questions, people, keep a track. One question you guys got 80% above. The other question less than 80%. It's very clear. Only 21 out of 33 got it right. 4 for pole, 7 for radius of curvature, 1 for focal point also. Arrewa, people, I like it. But the right answer, guys, is the center of curvature. If a ray of light is striking on the surface of a mirror, or let's say a ray of light is coming from the center of curvature, after reflection, it'll go back in the exact same path. Why? Because to that particular point, let me just draw it and show it to you guys for all those who have not attended the previous session. So imagine this is the point, guys. Now to this point, if I have to draw normal, the normal would basically be a dotted line or a straight line, which is connecting that point and the center of curvature. And if a ray of light is incidenting exactly at the center at normal, which is basically 0 degrees, then the angle of reflection will also be 0 degrees. So the reflected ray, which I'm going to show with yellow, would also be reflected back at the same exact path. And this point is nothing but your center of curvature. The distance from the pole to the center of curvature is the radius of curvature. That is your radius of curvature from the center of curvature to the pole. That is the midpoint of the mirror. That is your radius of curvature, and that point is the center of curvature. Very important, guys. Today we will be using all of that. All right. This is one of the standard incident rays that you guys need to remember in order to draw your ray diagrams. All right. It's a standard incident ray. All right. Anyways, guys, that's okay. Happens, but I hope you guys are clear with it, because today we'll be utilizing those. Whatever we have learned in the previous session, we'll be utilizing it today. All right. Anyways. Here's your leaderboard, guys. Palak G on the top, fastest to answer. Teddy G on the second. Yes, I do remember you, buddy. Anushri, Shanvi, high five, long time. Dear Dosi to you, dada. Aaron, the football player. Call Shilpi ma'am, please. Romeo. Look at that. Look at that. Romeo G, what do you think I'm doing here? Huh? What do you think? What is this? STD call service? Huh? Like back in the days and all, if you want to make a call, you'll go to those STD booths and make a call. No, what is this? Do I look like a yellow STD box to you people? That I have to call everyone, sit and call. Hey, I'm here to teach, dad. Anyways, surprise, Gauri, Kushi, Anand, Nirajana, and Mishti. Congratulations. Well done. How's married life? Huh? Interesting. Alright, yeah, I look like that. No, yeah, alright. Anyways, third question, guys. Third question. Here it is. This is the last backtrack question, and then we'll go on to the topic. Alright, so here it is. A very narrow light ray AB strikes the surface of a convex mirror as shown in the diagram. I can barely see the diagram. I'm very sorry, guys. But yeah, which of these do you think is the right option? Is it A, B, C, or D? I hope you guys can see it. A ray of light, it's a convex mirror, and a ray of light is incidenting on the convex mirror. After reflection, that ray of light is parallel to the principal axis. So after reflection, what would the reflected ray look like? Yeah, I know, even I can't see it properly. It's so small. I know. I have to come close to the screen in order to see it. So to figure out what to do, people. Try your best. Even if you get it wrong, it's okay. I won't count this for this thing. Don't worry. I won't count it for your. Okay. Tell me this, guys. Tell me this. If a ray of light is parallel to principal axis, if it's a convex mirror, after reflection, what should happen to it? If a ray of light is parallel to the principal axis, after reflection, what should happen? What should happen? I just want to check. I know it would diverge. Absolutely, it would diverge. Now, the way that it diverges, can you tell me something about that? The way that it diverges, can someone tell me a little bit about that? Like, what is so special about this ray of light that is diverging away once it incidents on a convex mirror? Exactly, it will appear to pass through the focus. It will seem like it's passing through the focus. Now in this case, this is the only ray of light where it would seem like it's passing through the focus. Here you see this, it's going in a different direction. Even though here also it's getting diverged away, but since this ray of light is parallel to the principal axis, after reflection it would seem like it is passing through the focus, and that is why option A is the correct answer. Alright, now guys, let me ask you this. How many of you guys knew this already, but because you guys were not able to see the diagram, you did not get the answer right? Be honest though, be honest. How many of you guys knew this? But okay, I am sorry to you people. Apologies, Shama Kardo ji. What to do now, because this whole question had to be put in like that. I'm really sorry, but I hope that you guys don't take it out on me later. But yeah, it was an unfortunate error, but I'll make sure that it doesn't happen again, right? So anyways, guys, sorry about that. Anyways, here's your leaderboard at the end of the third question. Once again, Teddy Gupta ji is on the top still. Somehow all these guys did manage to give the right answer. I don't know how. Anushri on the second, Kushi on the third, Mishti on the fourth. I am AKR. Hi, Anoop ji. Welcome AKR ji. Then it's Uday, Sanskriti, Akrar, Bhumika, and An Academy. Why? Anyways, fastest to answer. Congratulations. Well done, people. So that's it, guys. Let's get back into the topic now. Everyone, get back into the topic. Everyone, come back to YouTube now. Come back. Don't leave the Mentimeter though. We'll come back to Mentimeter after we're done with the topic. Now, the topic won't take too long because it's only ray diagrams of concave and convex mirrors. And we have about 6 ray diagrams for concave mirrors. If you understand those 6, convex would be also super easy because there are only 2 ray diagrams for convex mirrors. Alright, so everyone, once you're here, give me a quick OA so that we can get started. Let's go, people. Yeah. Oh, all right, Gauriji. All right. No consequence of all Abhishek sir. That's the bet. That's not consequence at all. I know, right? Exactly, Rivi. I in these next level. All right. Anyways, so guys, let's get started. There are 6 different ray diagrams for concave mirrors. Now, why do these ray diagrams change? Why is it so important? Because here's the thing, guys. Using the ray diagrams, you can predict where the image formation is happening. Or if you have the image with you, you can find out where the object is kept. So in order to figure out whether be it the object or whether be it the image, for that reason, we draw what is called as a ray diagram. Now, let me remind you, ray diagrams does not give you the exact position of the image or the exact position of the object. For that, you'll have to use your mirror formula. For that would come under numericals, where you have to find out the exact, is it 15 centimeter, 20 centimeter? That is something that you will have to figure out from your mirror formula. This will only give you a rough idea as to where the image formation or where the object is kept. Now we keep the object in 6 different positions and obtain 6 different images. All right, so that is why you have these things given over here. First is that when we keep the object is at infinity, for example a ray of light coming from the sun or a ray of light that is coming from a very distant tree, all of those are considered to be infinite. Now again guys, we know the exact distance in terms of light years and kilometers from Earth to the sun, but then because it's very far away, we are considering it as infinite. All right, so it's not that infinite means we do not know the distance at all. No, we know the distance, but it's very far away. Imagine a lens. A lens is only so much. The thing that we use for experimentation is generally only so much. So in comparison to that, the ratio of the size of a lens or a mirror compared to the object when it's far away, that is when we consider it to be infinite. Then when the object is kept between the center of curvature and infinity, that means we're bringing it a little closer. The third condition is when the object is kept exactly at the center of curvature. Fourth is when we keep it between center of curvature and the focus. Fifth, when we keep it exactly on the focus. And the sixth, when we keep it between focus and the pole. Now again guys, in all these cases, the type of image that you get might vary a little. So with that said, let's get into it. All right, so everyone, listen up. Everyone, what I want you guys to do is take your pen and paper and draw these ray diagrams with me, because just by listening to it, you'll not understand anything. Trust me, ray diagrams is not something that you just listen and you'll understand. No, I know that you guys watch Krish and all back in 2010, but it doesn't work in real life. So everyone take your pens and papers. I'll give you 30 seconds. Let's get started. Oh, awesome. All right, let's go. The first one is this. When the object is kept at infinity. See guys, when the object is kept at infinity, we are considering that the rays of light coming from that object is parallel to the principal axis. All right, so I am going to take 2 or even 3 or even 4 rays of light parallel to the principal axis. You can see this, all these rays of light are parallel to the principal axis. Now guys, according to the standard incident rays of light, can you tell me if 2 rays of light are coming parallel to principal axis, after reflection, what should happen to it? If it's a concave mirror, then? I know, Manaswini. Yeah, I was a little busy. Now I'm back. Exactly, guys, exactly. After reflection, these 2 rays of light will pass through the focus. Now, what is focus? I have already talked about it in the last session. So if you haven't watched that video yet, make sure you watch it. So in other words, guys, after reflection, the rays of light would, even if I take n number of rays of light which are parallel to the principal axis, after reflection they will all meet at the focus. So the image is exactly formed at the focus when the object is kept at infinity. You can take the example of a magnifying glass. You can even take the example of your solar cookers. Even in solar cookers also, what you do is that you keep the cooker exactly at the focus. Why do you keep it exactly at the focus? Because you want those rays of light which are coming from the sun, which are parallel, to reflect and meet at this point so that the temperature can increase. Because if only one ray of light is coming and falling, it will take a longer time. So this way the food would cook much more faster. So what you do, you place a concave mirror and you place the cooker exactly at the focus so that all those rays of light would come and meet at that point so that the food can cook much more faster. So this, my friends, is a real-time example of it. Now, if you talk about the type of image formed over here, the image is actually a real image. Why is it a real image? Because the rays of light are actually meeting. It's not like they're pretending to meet. They're actually meeting, and real images are always inverted. So here also the image that you get will be inverted in the sense, if this is the object, the image will be upside down. It will be like this, upside down, so it will be inverted. And finally guys, the image is going to be point sized. Why is it point sized? Because if you look at the image, guys, it's going to be very small. So here the image that you get is actually a diminished image. To be more precise, it's actually point size. It'll be a very small image. Now if you've ever played with your magnifying glass also, you will be able to figure it out. Now again, I'm not going to get into lenses now, so it's pretty much the same thing, but we'll talk about lenses later on, right? Is it clear, people? Understood? Everyone clear with This so far all good, all great. Everyone done. So we have three types. Again, the type of image formed is that it's a real image, it's inverted, and it's also a point-sized image. And again, after reflection, these rays of light are meeting at the focus when the rays of light are parallel to one another. Simple. All right. Second one is when the object is kept between the center of curvature and infinity. Now you have a known distance between infinity and center of curvature. When you have an object kept, you need two rays of light. You need only two rays of light to form an image. So here also you need two rays of light. One ray of light which is parallel to the principal axis, another ray of light that is passing through the center of curvature. If a ray of light is parallel to the principal axis, after reflection, it will pass through the focus. That is what is seen over here. After reflection, it will pass through the focus. So you can see this, I'll just mark it with yellow. So this is one ray of light that you have. Another ray of light that is passing through the center of curvature, which I'm marking with green, after reflection will get reflected back in the same path. So when it gets reflected back in the same path, both these rays of light are meeting at this particular junction. They're meeting at a point between the center of curvature and the focus. Between these 2 points, between the center of curvature of the length of the mirror and the focus of the mirror, these rays of light are meeting. And my friends, that is where the image formation happens. This is where the image formation happens when the object is kept where? Between the center of curvature and infinity. Is it clear? Able to understand this, guys? Is it clear? Now guys, tell me what is the type of image formed over here. Everyone quickly in the chat box, what is the type of image formed? Once again repeat it. One ray of light which is parallel to the principal axis, which is one standard incident ray of light. After reflection, it will pass through the focus. We have just seen that. One more ray of light is passing through the center of curvature. And if a ray of light is passing through the center of curvature, after reflection, it will get reflected back in the same path. So both these rays of light are meeting at this particular point. One ray of light passing through this one more ray of light over here. So what is happening is that they are both meeting at this point, and so the image is going to be formed over here. Alright, and this image, if you look at it, is between the center of curvature and the focus. And the speciality or the features about this image is that yes, it is a real image. Yes, it is inverted. You can see this. The object is like this, but the image is upside down. So the image is real, it's inverted. And finally, guys, tell me, is it bigger than the object or is it smaller than the object? So why not at point B? Which point B? This point, you see this? This is basically the object. AB is the object. The image is formed is A dash B dash. That's all. The image formed is A dash B dash. And if you look at the size of the image, this is the size of the object, but this is the size of the image. So it's much more smaller than the object. So the image is diminished or smaller than the actual object. Got it? Is it clear now? Clear? So at what distance is infinity? You can take any distance as infinity. Now, let's say if there's a tree that is 500 meters away, you can take that also as infinity, depending on what is given in the question. Because generally, again, talking about the size of the mirror, we don't take a mirror which has like what to say, we don't take mirrors which are 1 meter in diameter and all. We take smaller mirrors only, So in comparison to that, for that mirror, that distance is also very far away. Getting it? So it depends on what is given in the question. So don't worry about that. Alright, it will be mentioned in the question. Yes, Bharat, we have Menti also. So this is the second one, guys. Moving on to the third one. When the object is kept at the center of curvature. Again, guys, I'm going to take two standard incident ray of light. One ray of light which is parallel to the principal axis. Alright. One more ray of light that is passing through the focus. Alright. Because again, guys, we have three standard incident ray of light. One is when it's parallel to the principal axis, one when it is passing through the focus, and the other when it is passing through the center of curvature. And I've already talked about all these three in the last session, so make sure you watch all of that, right? So anyways, after reflection, this ray of light, what will happen to this one, people? Quickly, what will happen? A ray of light that is parallel to principal axis, what will happen after reflection? Quickly, chat box. What is this? Menti for sure will have the powerful lens and all later. Exactly, it will pass to the focus. So one ray of light passing through the focus. A ray of light that is already passing through the focus after reflection, what will happen to it? If a ray of light is already passing through the focus after reflection, what will happen to it? Yes, we have Menti, we have polar, eh? Exactly, it will become parallel to the principal axis. That is another standard incident ray, people. So the image is going to be formed exactly at the center of curvature itself. When the object is kept at the center of curvature, the image is also going to be formed at the center of curvature itself. Very important to remember, guys. Please pay attention. Everyone, I know that it's a little distracting, but I know YouTube is a little distracting, but yes, pay attention, because you have a lot of marks coming from this chapter. You have a lot of marks coming from this chapter. And trust me, all of you guys here, I know for a fact you want to score 80 and 90%. Yes, I am sure that if you are sitting over here on a Monday afternoon, you had a lot of better things to do, but you're still staying here because you want to score good marks. So that means that you'll have to pay a little bit more attention as well. All right, so everyone, listen up. Prajwal, please type your doubts and send it to me. All right, so yes, guys, once again, a ray of light parallel to principal axis. After reflection will pass through the focus. One more ray of light which is passing through the focus after reflection will become parallel to the principal axis. And when you join these two rays of light, you can see that they will meet at a point exactly at the center of curvature itself. So if the object is kept at the center of curvature of the lens, the image will also be formed at center of curvature itself. Now guys, tell me, what are the characteristics of the image? What are the characteristics of the image? Exactly, Kirti. If you look at the size of the image, guys, just talk about the size of the image. Height of the object and height of the image is exactly the same. So the image is going to be of the same size. Secondly, is it a real or exactly, guys? Amazing. It is going to be a real image because the rays of light are actually meeting. And because it's a real image, it's also going to be inverted as well. It's upside down. Simple. All right, guys. Everyone clear with the topic so far? 3 ray diagrams done and dusted. Anyone who has a doubt in any of these 3 ray diagrams? One, when the object is kept at infinity. Second, between C and infinity. Third, when it's kept at C. All clear? Yes? Oh, is it, Mayuri? Awesome, da? All clear? All right. Okay, moving on. Yes. The next is, we're going to bring it a little bit more closer. When the object is kept between center of curvature and focus. Again, guys, I'm going to take 2 more rays of light. All right, now guys, listen carefully. 1 ray of light parallel to principal axis. 1 more ray of light passing through the center of curvature. All right, my center of curvature is over here. 1 more ray of light passing through the center of curvature. The reflected ray I'm going to show it with yellow color just so that you don't get confused. 1 ray of light parallel to the principal axis. After reflection, what will happen? It will pass to the focus. 1 more ray of light that is passing to the center of curvature. After reflection will pass through the center of curvature itself. And basically, guys, if you extend these 2 rays of light, they will meet at a point between the center of curvature and infinity. So what I'm trying to say is this, guys. When the object is kept between the center of curvature and focus, the image is going to get further and further away from the mirror. So here in this case, the image is going to be formed between the center of curvature and infinity. Now I'll tell you an easy way to remember it later on once we go to the table. For now, just understand the ray diagram. Are you guys clear with the ray diagrams? Hi, Samreen, Noda. I just saw your message now. Is it clear? Is it clear, people? Able to understand? Is it clear? 1 ray of light passing to the parallel to the principal axis. Another ray of light passing to the center of curvature. After this, they'll both meet at this point beyond or between C and infinity. And if you look at the size of the image, is it small or bigger, guys? Is it smaller or bigger than the object? If you look at the size of the image. Exactly, guys. This is a magnified or an enlarged image. It's much more bigger than the object. Look at the size of the object, look at the size of the image. It's much more bigger than the object. You can see it's enlarged and or it's magnified or enlarged, and it is real and it is inverted as well. All right, this is your next ray diagram, the 4th ray diagram. All right, clear? Understood? Anyone who did not understand this? First one, a ray of light parallel. Again, in most cases, people, we are going to take 2 rays of light, 2 standard incident rays of light, one parallel to principal axis, the other passing through the center of curvature. Only in very rare conditions, we're going to take 1 more ray of light that is passing through the focus. But remember, all you need is 2 rays of light. All you need is 2 standard incident rays in order to form the image. Which of those are you going to choose? That is up to you people. Got it? Okay, one more time now. 1 ray of light which is passing through the, one is parallel to the principal axis. After reflection will pass to the focus. One more ray of light that is passing through the center of curvature will get reflected back in the same exact direction, and when you extend these two rays, these two reflected rays, they will meet at a point between the center of curvature and infinity. Alright, and the image formed is much more magnified or much more enlarged. It's real and it's inverted as well. Alright, fifth is when the object is kept at the focus. Alright, when the object is kept at focus, guys, you cannot take the second incident ray, that is a ray of light passing through the focus, because the object itself is kept on the focus. So I'm going to take one more ray of light which is parallel to principal axis, and one ray of light that is passing through the center of curvature. Again, guys, draw the reflected ray. I'm going to use red, or I'm going to use blue. I don't know if you can see blue. You can see blue, right? So a ray of light which is parallel to principal axis, after reflection will pass through the focus, and one more ray of light that is passing through the center of curvature, after reflection will pass exactly the same. And if you look at it, guys, these two rays of light are parallel to one another. Are they meeting? Are they meeting at a point, guys? Now remember, two rays which are parallel, two lines which are parallel, will they meet? Will they meet at this point? No. But we are assuming that these two parallel rays of light are meeting at infinity, because no two rays of light are exactly parallel. It will meet, but it's at a point at infinity. Some point at infinity this is going to meet. So we are assuming that these two rays of light are meeting at infinity. Alright, remember, guys, when the object is kept at focus, the image is formed at infinity. This is exactly the opposite case that we did in the first one. Remember, if you go back to the first case, when the object was kept at infinity, image was formed at focus. Now the opposite is happening. When the object is kept at focus, image is formed at infinity. Alright, and if you look at the characteristics of image, it's a real image, it is inverted in nature, and it is also enlarged again or magnified. Got it? Clear, guys? Highly magnified. Yes. Yeah, exactly. There's nothing called as parallel. Everything is Momaya. Exactly. Exactly. Clear, people? Sir, image formed is exactly, people. Exactly. Any doubts, guys? Did I miss out on anything that is important? Did I miss out on any important doubts? No, right? Alright. Okay, now. So I'm going to go out, guys. I'm going to go on to the next one. The last one is this. This is the last one for concave mirror. Then we'll go on to convex. Convex is super easy. If an object is kept between the focus and pole, if the object is kept between focus, see, at every step you're trying to bring the object closer and closer to the mirror. But what you notice is that as you bring it closer and closer, the image is going further and further away. As you bring the object closer and closer, the image is going further and further away. But once you cross the focus, and keep an object between focus and pole, the image formed is going to be completely different. So everyone, listen up very carefully. This is like, you know, as Abhishek sir says, this is the SRK of all ray diagrams, you know, like the Shah Rukh Khan of all ray diagrams. It's completely hard, okay, like a totally different one. So yeah, a ray of light parallel to principal axis. One more ray of light passing through the focus. I'm going to take these two incident rays itself. All right. After reflection, my first ray will pass through the focus. Simple. After reflection, this ray of light will also pass through the center of curvature. Now guys, tell me, what do those rays of light look like? The reflected rays. Do they look like they're going to meet at any point in life? Do you think that they'll meet at any point in life? Exactly. They are diverging away from one another. At least in the last case, they were parallel. In this case, they are diverging away from one another. So what's happening is that here the rays of light are never meeting. They are never ever going to meet. So what we are going to do is a little different. We will extend these rays of light beyond the mirror. And when you do that, guys, when you extend these reflected rays beyond the mirror, it will meet at a point behind the mirror. This is the only case in a concave mirror where we are getting a virtual image. Why virtual? Because the rays of light are not actually meeting. They are diverging away from one another. So what we are doing is that we are extending them and making them meet at a point behind the mirror. And we are going to get a virtual image in this case. And if you look at the size of the image, this is the size of the object, this is the size of the image, so it's much more enlarged, and finally it's an erect image. Why? Because the object is also like this, image is also like this. That's all. Got it? Is it clear, people? Understood? Is it really? Oh my god, I didn't know. Is it clear? Understood, people? Exactly. We are virtual, erect, and diminished. Diminished, this is actually what to say, enlarged. VEE make more sense. Diminished would be for your convex mirrors. This is VEE. Virtual, erect, and enlarged. Alright? Done? Awesome, guys. Everyone clear with it? Give me a quick OA. OA. Clear. All good? All good, people? Yes, we have Menti. We have to do a little bit more, and then I'll come back to the Menti after this. Yeah. Hi, Utkarsha. Long time no see. Clear? Alright, guys. Confused between erect and real image. Erect images are those. Imagine this, This is the object. If the image is also upright in the sense it's exactly like this. It's not upside down. Alright? If it's like this, that is an erect image. Like when you're standing in front of a mirror, your head is in the place of head itself, leg is in the place of leg itself. That is erect. Alright? Inverted would have been, in place of your head, you're able to see your leg, and in place of your leg, you're able to see your head. That is inverted. Alright? Real image means the image that are formed by the actual meeting of rays of light. When the rays of light are actually meeting, that image that is formed is a real image. Now again, there are certain characteristics like real image can be caught on a screen. All of that is different. But here when you talk about ray diagrams, if the rays of light after reflection, if they are actually meeting, that is a real image. If they are not meeting, like in this case, the rays of light are after reflection, they're going away. But we are making them meet at a point. That is a virtual image. That's all. Got it? Clear? Make sense? Go Jujubi here. Yeah, Jujubi is Ada. Yes. Jujubi is easy. So yeah, guys, this is the table, people. Guys, everyone take a screenshot of this one. Everyone take a screenshot of this one. Super important. If you remember this table, guys, it'll be super duper easy. An easy way to remember this, again, here it is. At infinity, image is formed at F. At F, image is formed at infinity. Opposite. When the object is kept between C and infinity, the image is formed between C and F. When the object is kept between C and F, image is formed between C and infinity. So it's basically, guys, ulta pulta of each other. You don't have to remember the entire table, just need to remember the first three and the last one, and it's done. The first three is all you have to remember. See, when the object is kept at infinity, image is formed at F. In the fifth case, when the object is kept at focus, image is formed at infinity. When the object is kept between C and infinity, image between C and F. Object kept between C and F, image between C and infinity. Third, when the object is kept at C, image will also be formed at C. And finally, guys, when the object is kept between the focus and pole, then the image is formed behind P. This is the only different case that you have. Got it? So yeah, guys, take a screenshot of this. Remember this, because you will need this in your final exams. Alright? Alright, so talking about the image properties once again, you can take this down. Diminished, inverted, real, diminished, inverted, real. Again, all real images are inverted, so an easier way to remember that. And this is the only case where you're getting a virtual and erect image. Otherwise, you're getting enlarged or diminished or even same sized image, right? So yeah, guys, that's pretty much it. With that said, let's now get into convex mirrors. Ready? Everyone? Everyone ready? Ready? People, chat box. What happened to the Josh? Yeah, all of you guys, all Josh and all is coming down. Like it's all melting slowly, like fat, like butter. Like because of the heat and all, you're sitting in one place. The heat is just melting down all the butter now. Slept. Wake up, wake up. Show my left thumb. This is my left thumb now, by the way. Yes. All right. Let's go. Convex mirrors. There are only two things that you need to remember. Object kept at infinity. Object kept in front of the mirror, no matter where you keep it. Alright? Because no matter where you keep the object in a convex mirror, very simple case, no matter where you keep the object, infinity, close, really close also, it really doesn't matter. The image that you're going to get will always be virtual. It will always be erect. It will always be diminished. Always, guys, always diminished, always virtual, always erect. No matter where you keep it, the image that you're going to get is like this itself. But ray diagrams is going to be a little different. When the object is kept at infinity, again, Well, the rays of light are coming from infinity, right? From parallel to the principal axis, they're coming from infinity. After reflection, they will get diverged away. But the diverging of the ray of light also happens such a way that when you extend them, they appear as though they are meeting at the focus. They appear to meet at the focus. That is the key word. They are not actually meeting, but they are appearing to meet at the focus. That is the thing about convex mirrors. So the image that you're going to get is a virtual image. It's erect in nature and it's also diminished. All right. And when the object is kept at any point in front of the object, in front of the mirror, again guys, remember in this case, in the case of a convex mirror, the focus and the center of curvature lies behind the mirror, not in front of it. Because again guys, I told you that a convex mirror and a concave mirror is basically a part of a sphere. So here the sphere would look like this. The sphere will not go into the front, it will go in the back. So the center of curvature and focus would lie behind the mirror. So if an object is kept in front of the mirror, one ray of light parallel to principal axis, after reflection will appear to pass through the focus. One more ray of light which is appearing to pass through the focus after reflection will get reflected back in the same exact direction. So when you extend this ray of light guys passing through the center of curvature, you can see that the image is formed between the pole and the focus. So when the object is kept, no matter where in front of a convex mirror, the ray diagram would look like this. But again guys, as you bring it closer and closer, as you bring the object closer and closer, the image size will get a little bigger and bigger. Once you do the ray diagrams, you'll understand it. But yeah guys, this is all you need to remember. And yeah, the best way to remember this is Vedantu, Ved. That's all. Vedantu's Ved. That's all. Image formation. Virtual. Someone gave me the idea right now. Erect. And finally, diminished. That's it. That's it, people. That's all. So the image in the case of a convex mirror will be formed between the focus and the pole. That's all. No matter where you keep the object, this is what is going to happen. Oh, Abhishek sir said this. Copying Abhishek sir. Yes. Alright, so yeah guys, if you talk about again, this is the table. You can take a screenshot of this one. When the object is kept at infinity, image is formed at F. The characters, the properties of the image is that they are diminished, erect, and virtual. When the object is kept anywhere in front of the mirror, the image is formed between pole and the focus. Image is going to be diminished, erect, and virtual. Alright guys, and are you guys ready for the quiz now? Ready? I know, right? AK sir is everywhere. AK sir is like God. Ready? Ready for the quiz now? Yo people, in the chat box. Yeah, Josh, I want to see the Josh. I even put this thing and all now. Good afternoon. Yeah, good afternoon. Welcome. So yeah, people. Before we get into the quiz, do not forget to like, share, subscribe. And I would also like to talk about Vedantu's Pro subscription courses before we get into the quiz. So yeah, guys, I'm sure once again that a lot of you guys here need a lot of help. And that's why you're here. Maybe you just want to revise a concept. Maybe you have not understood the concept that were taught in school, or whatever the problem is. Maybe getting your doubt solved has become a problem. Whatever the problem is, guys, Vedantu is here for you guys. We are here for you guys to ensure that you are getting 100% knowledge and 100% marks in every single topic. Be it physics, chemistry, bio, math, English, social science. All 6 subjects would be covered here in your Vedantu's classes. And with that, guys, we are also giving you the assurity that yes, you will see an improvement in your score. And that is Vedantu's improvement promise. I'm sure there are a lot of you guys would have already seen the Amir Khan ad of this. Vedantu's improvement promise is very simple. If you enroll with us and you don't see any improvement in your score, you, my friend, can claim your complete money back. But that is the kind of guarantee we are giving you, that yes, you will see an improvement in your score. And trust me guys, no place in the world will give you that guarantee that if your scores don't improve, then give us your money back. That never works. But here at Vedantu, we are giving you that guarantee also. Unlimited live sessions with the highest level of quizzes, which not only test your memory, test your brain, test your understanding, but also gives you a chance to understand yourself by competing with your friends, to give you an opportunity to see how good you can get in that particular subject. With this, guys, you can get all the recordings available. Every single session is live. You can get those live recordings later on and watch it, and even take the quizzes while watching the replay also. With this, guys, you can also take down all the notes. Every single PDF is downloadable, so you can download the PDF and go through the notes how many ever number of times you want. And to top it all off, every single session will not just have one particular teacher, but with the master teacher you will also have the class teacher to ensure that every single doubt of yours is cleared inside the class itself. Unlimited doubt solving in class, real-time doubt solving with the best of the best tests and assignments. And the questions of these tests and assignments are like, it's like beautiful questions have been chosen to ensure that you guys are getting the best of the best. And yes, guys, with that you have KVPY preparations, NTSA preparations, Olympiad preparations, you have breathing exercises, you have classes for stress relief. Tons and tons of activities are going on for a holistic improvement in your education, and not just focusing on your CBSE syllabus alone, because everything goes hand in hand. If your health is good, you'll also be able to do better, and that is what we've understood, and that is what we're trying to achieve over here. So what are you supposed to do to enroll into the courses, guys? It's quite simple. So right now you're watching this video. Yeah, this is me. Yeah, I feel so good. So yeah, anyways, this is me right now. Apart from the ad, all you have to do is this, guys, go to the description of this video, click on register to Vedantu Pro subscription right now. Click on this link, guys. This link is all you need to know, all you need to enroll into any course at Vedantu. So what you can do is change your grade over here. Click on change. Whatever grade you're in, 10th CBSE, just click on that. Click on get started, and this is what you're going to get. Now, guys, there are 3 different types of courses offered by Vedantu. One is Vedantu Lite, the other is Vedantu Classic, the other is Vedantu Pro Plus. Now, Lite is everything that you need. Lite has your live interactive sessions, test series and assignments. You have your doubt solving inside the class, but there is no doubt solving outside the class. But in Classic, you have that also. You have doubt solving outside the class as well. And in Pro Plus, though, you have doubt solving outside, inside, and you also have someone called as a personal mentor. So the personal mentor will ensure that all of your doubts are cleared. He'll motivate you. He'll be with you from the start until the end to ensure that you're in the right track. Now, guys, the price of this also is different, but let me tell you this, that this is the best price in the market. Even though it might seem like a very big number, you're getting a flat 10% discount on top of it. So here's the thing, guys, if you enroll for the 1-month program, that's 2,600 rupees. But if you use this link that I just gave you right now, that is given in the description, you'll get a flat 10% discount, and the price drops down to 2,340 rupees. No inclusive and all that, everything included. This is the price that you're going to pay. Now, let's say that you're paying 2,400 rupees. Just for this namesake, let's say you're paying 2,400 rupees. In that 2,400 rupees, you're getting all 6 subjects: physics, chemistry, math, bio, English, social science. All 6 subjects you're receiving it. So that means that per subject, how much are you paying, people? Per subject, you're paying roughly about 400 rupees a month, which is the exact same amount of money that you'll be paying outside also. So it's pretty much the exact same thing. Getting it? And yes, you can study in the comfort of your home. Don't worry about coronavirus also. All right. And yeah, the year-long program is 29,699. If you have the money, go ahead with that, or go with the 1-month program and then try for yourself and check out whether you want to go for it further ahead or not. All right. These are all the teachers. For all the AKR fans out there, Abhishek sir, Amrit sir, Surabhi ma'am, we have some amazing teachers, amazing set of teachers to teach you people, to inspire you guys to make sure that you're in the right track. We have results that we have gotten in the past. These are all the timetables of your subjects. You can check it out and customize it for yourself. And yes, you can check out the results, and also you can check out the testimonies of parents and your colleagues, your seniors who have gone through the exact same thing. Right? So yeah, guys, that's pretty much about Vedantu's courses. Now let's get back into the Mentimeter, because I know that you're scolding me on the inside right now. So let's get back to it. All right. So everyone who's left the Mentimeter, join back the Mentimeter quickly. And all you have to do is this, guys, go to www.menti.com and enter the code 58893579. Once you're in, let me know. Come on, quick. Oh, is it? I'll be done another 5 more minutes. Oh, Ashmiji, what's up? What's up? It's all right, Namanji. Welcome back. Long time no see. What's up, da? How you doing? I know, right? I didn't see a lot of chat. I was just talking. All right, come on, people. Let's go. Sure, sure. Yes, 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 Abhi, yes, Siddha, yes. Hi, Rishi, what's up? Welcome back, welcome back. Alright, guys. So once you're in, let me know so that we can get started with the quiz. These are the last 4 questions that I have in store for you people. Okay, 5 questions, no? Yeah, including this one, it's fine. Alright, so I'll start the quiz, people, in 5, 4, 3, 2, 1. Let's go. Let's go. Let's go. The first question, here it is. What condition is necessary for a real image in a concave mirror? Object smaller than its image, object bigger than its image, object inside the focus, object outside the focus. Which of this condition is necessary for a real image in a concave mirror to be formed? Let's see how many of you guys were listening and how many of you guys were watching games or playing games, taking this name of Anoop Sir session and playing games. Let's see, let's see. Yeah, I do remember. You guys remember the bet? No, you guys remember the bet, right? Yes, please remember it. Please remember it, alright? Yeah. Anyways, so here it is, guys. The answer to this question is option number D. 9 people out of 26. Yes. Well done, people. Well done. I like it. I like it so much. The answer is outside the focus. Yeah? Because if it's inside the focus, you're going to get a virtual image, right? Between focus and pole, if you keep the object, you're going to get a virtual image. So what is that one condition that you must satisfy? The object must be behind the focus. Look at that. That is psychopath face. Idiot, psychopath. I am gonna squeeze you for this wrong answer kind of face. Anyways, Teddy was the first to answer, followed by Kushi, then it's Mishi, then it's AKR sir, welcome. Anushri, Aaron, Shanvi, Haida, Uday, and Sanskriti, and Akrar. Congratulations. Well done. And next question. Here is another one. The 5th question, people. Let's go ahead and solve this one. Here we go. The question is, very big question. A student using a concave mirror locates an inverted image the same size at the same position as the object. Which one of the following condition is justified? The object is nearer to the pole of the mirror than to its focal length. The object is at the center of curvature of the mirror. The object is at the focus of the mirror, or only rays parallel to the principal axis can form a real image. A student using a concave mirror locates an inverted image same size and same position as that of the object. Which of this should be the conclusion? No, Ashmiji, no. Oh, Sanskrit. Oh, how did you go? How did you do it, Daman? Sir is kill. Yeah, no, if I want to kill mosquitoes, I'll be like this. I'll become Jackie Chan at that time. I'll go all slow. I'll follow their path and then I'll catch them. Getting it? Like you watched this thing, no? What is that? Karate Kid. I'll be like that. Anyways, 19 out of 25. Is that 80%? I don't think so. So that's another question. Less than 80%. That's less than 80%. You know, this is 80. Huh? Hey. Don't lie there. Don't lie there. I don't trust you people. I want the mathematical calculation to be shown right now. I want the 76%. No? I like it. Anyways, 19 out of 25. Congratulations, guys. Congratulations. The right answer is option number B. When the object is kept at the center of curvature, then the image formed is going to be in the same place. It's going to be of the same size, and it's also going to be inverted in nature. That is the only condition we are going to get a same sized image. No, I don't. Oh, 100%. Yeah, Riddhi, why not? Yeah. Bakra likha hai na, yeah. Like on my forehead, it's written as Bakra, no? That's why. Anyways, the answer is option number B. Teddy Gupta ji on the top. Anushri ji unfortunately chose the wrong answer. Teddy was the first answer. Then it's Kushi, Mishi, AKR, Aaron. Then it's Shami, Palak, Bhumika, Anushri, and Nishita. Congratulations. So people, how many of you guys? Okay. How many questions did you get more than 80%? How many questions? It's very hard for me to count with my fingers. It's very hard for me to count with my fingers. Come on, people. How many? I like it. Alright, 6th question. Here we go. Sixth question, one question. So hard for me to count with my fingers. A ray of light parallel to the principal axis of a concave mirror is reflected back. A ray of light parallel to the principal axis of a concave mirror is reflected back. Pass through the center of curvature, the center of the sphere, a ray through the focus, parallel to the principal axis, as if it came from the focal point. A ray of light parallel to the principal axis of a concave mirror is reflected back in what direction? Let's go. Too late, Kirti, too late. The challenge was to get 5 questions right, more than 80%. You see the smirk on my... Damn. All right. I take it back. Not bad, people. Not bad. Amazing job, guys. Amazing job. Give me a high five. That is absolutely bang on, people. I wasn't expecting that. That was a slap on my face, but nonetheless, I'm super proud of you guys. Exactly correct. If a ray of light is parallel to the principal axis after reflection, it will always pass through the focus, and you guys have done an amazing job in understanding and answering the question. Super proud of you guys. Yeah? 2 questions, Ladan. 2 questions now. All right. Fingers crossed, touch wood, please not. Anyway, Steady, Kushi, Mishti, AKR, Aaron, Shanvi, Palak, Bhumika was the first to answer. Palak was the first to answer. Bhumika, Nishita, and Mayuri. Congratulations. Well done, people, well done. Moving on to the next question. Here is the 7th question. We have 2 questions left. Let's see if you guys can make it count. Here we go. The 7th question. The image of an object which puts in front of a convex mirror is formed at position of object, at double the distance of position of the object, at half the distance of the position of the object behind the mirror. The image of an object which you put in front of a convex mirror. If you have a convex mirror and if you keep an object in front of it, what does the image formed look like? That is the question, in other words. At position of the object, at the same position of the object, double the distance, half the distance, or behind the mirror. Kill the paper. Awesome, Naman. Awesome. Proud of you. Yes, Kirti. 1st of September. It's a long way from now. Long way. And yeah, every birthday passes, I feel old. I feel like... anyways. The right answer to this question is option number D, and 24 of you guys got the right answer. That's once again more than 80%, I believe. Congratulations, guys. Congratulations. All right. 1 for option A, 1 for option B, and 2 for option C. But the right answer is option number D. Congratulations. It's behind the mirror itself, because you will always get Ved. Remember Ved? Virtual, always direct, and always diminished. And virtual images are formed behind the mirror. So in this case, it's going to be behind the mirror itself. Teddy was the first to answer. Kushi on the 2nd. Eka Sir the 3rd. 4th is Aaron. 5th is Mishti. 6th is Shani. 7th is Palak. 8th is Bhumika. 9th is Nishita. And 10th is Mayuri ji. Welcome to the leaderboard. Congratulations, guys. Congratulations. 3 out of 8 is what it is right now. What is focal plane is nothing but if I take a 2D figure, like for example, let's say a paper. Let's say it's a 2D figure. If I take a paper and place it at the focal point, of the mirror, that is what is called as a focal plane. It is just for reference. It's a plane in the sense it's a 2D structure. If you place a paper it has very less thickness, right? So if I place a 2D figure in the focal point of a mirror, that is what is called as a focal plane. That's all. All right. Okay. Now last question, guys. Let's finish it off with this one. Last question. If you guys win this, I still don't have to call Abhishek sir, because you still get only 4 questions right. All right. Let's go. Last question, guys. Last question. Let's go. The question is, where will the image in a convex mirror be if the object is at infinity? Where will the image in a convex mirror be if the object is at infinity? Options: at focus, at pole, between pole and the focus, or none of the above. Such an easy question, daddy. Why, oh why? Okay. No, dad. No. This is cheating. This is cheating. You guys are trying to make me bakra. No. Click on this pole to see the percentage of which pole. This one. Oh, you can see that. Is it? Oh, this one. Okay, let me just check it out. Let me just see. Thank you, Mayuriji. Mayuriji knows more about Mentimeter than I do. It's very nice. Very interesting. After results come. Okay. So yeah, guys, 2 more seconds. 1 and you're done. Here we go. Pole. That's a bad laugh, but then yes, people. 58% with who gave the right answer. Congratulations, 58%. I like it. Anyways, guys, the right answer is that focus. Now, always remember this, guys. If a ray of light is coming from infinity, that means that you're going to take it that you're going to assume that the rays of light are parallel to the principal axis. And if a ray of light is parallel to principal axis, it will form at the focus itself. The image will be formed at focus. Be it concave or convex mirrors, it will form at the focus. So please don't forget this. I really thought that every one of you guys would get it right. If the object is kept at any other place, then yes, the image will be formed between pole and focus. But if the object is kept at infinity, the rays of light are coming parallel to principal axis. After reflection, will form at the focus. Anyways, that's all, people. That's all. And with that, Mr. Anoop Manoharan, Anoop the Great, has won today's challenge. I would like to thank my parents, my grandparents, my LKG, UKG and pre-KG teachers for teaching me ABCD so that I could get to this position and beat you guys all like this, left, right, center. Thank you. Thank you. Anyways, the winner for today's quiz is Teddy Gupta. Yes, everyone is going to remember you now. Congratulations. Second is Kushi, third is Mishi, fourth is AKR, so fifth is Palak, then it's Bhumika, then it's Aaron, then it's Shanvi, Nishita and Uday as well. Congratulations. Well done, guys. Well done. Yeah, guys, that's all. You have to be very thankful to everyone there. What do you think? LKG, UKG is simple or what? Anyways, guys, by the way, like I told you, the pro exclusive micro courses, if you enroll into the course now, you can also enroll into my course. I will be teaching there on Vedantu platform for you guys to ensure that you guys are in the right track. And we'll also have some amazing teachers. All the teachers on who are teaching on Vedantu English the Vedantu platform right now you'll be able to attend every one of their sessions as well. So yeah, and Vedantu's improvement promise gives you that guarantee that without any doubt you can take up the courses, right? So anyways, that's pretty much it from my side. This is your homework question, by the way. You can take a screenshot of this one, put on the answer in the comment section. Let me see how many of you guys are able to give the right answer. I know, this is actually bad. You know why? Exactly. How could you guys get the last question wrong? Was it really that hard to get that question wrong? I mean, it was a simple question. Such a simple question. Anyways, so yeah, guys, don't forget to like, share, subscribe. And since you guys have been a great sport, I have decided to call Abhishek sir. Let's see if he picks up the call. I am going to make the call anyways. You guys can see it. I'm not cheating. You guys can see it. Alright, no cheating. You can see Abhishek's, Vedantu's.
Namaskar. The new year brings a sachet of hope in the form of COVID-19 vaccine. The vaccines made in India are totally safe, effective, and with good immunogenic response against COVID-19 disease. So trust the vaccines made in India. So take the vaccine at your turn and do not believe in hearsay. Remember, dawai bhi aur kadai bhi. Even after taking the vaccine, continue to wear a mask, observe physical distance of 2 meters, and regularly wash hands. For more information, visit www.mohsw.gov.in or call National Helpline number 107. ನೀವು ಕರೆ ಮಾಡುತ್ತಿದ್ದ ವ್ಯಕ್ತಿಯು ನಿಮ್ಮ ಕರೆ.
Got it? No, that's all. Peace, that's it. Called on, he didn't pick the call, he never picks up the call. What can I do? Anyways, that's all people, that's all for today then. That message is too long now. I'm like, for every call you have to listen to the whole thing and then. Anyways, yeah, Nadiji, I failed today. I'm sorry. Sorry guys, I'm sorry. But yeah, did you at least did everyone of you guys understand the concept today? Forget about all the fun and everything, but did you guys understand the concept? Yes or no? Did everyone of you guys understand it? Is it clear? I can't skip it I don't know. I can skip it with other people, but I can't skip it with Abhishek sir. That's his ringtone, I guess, for some reason. I know, exactly. Anyways, ನೀವು ಕರೆ ಮಾಡುತ್ತಿದ್ದ ವ್ಯಕ್ತಿಗಳು ಇವಾಗ ಕಾಲ್ ಪಿಕ್ ಮಾಡಲು ಇರಲಿಲ್ಲ. Anyways, so yeah guys, that's all for today. Thank you for joining, guys. I'll catch you guys in the next one. Take care of yourselves, stay safe, stay blessed. Thank you. And if you want to reach out to me, guys, you can also reach out to me on this anoop.manoharan@vedantu.com. I'll be here. Thank you for joining. I'll catch you guys in the next session. Take care of yourselves. And unfortunately, yeah, my screen went off. Alright, so yeah, bye people. Catch you guys later. Take care. That was Kannada, by the way. That was Kannada. I'm from Bangalore, right? So knowing Kannada is very important people. So yeah, that's it guys. Bye bye then. I know I couldn't invite any of you guys. I couldn't even invite Abhishek sir because of COVID-19 restrictions and all that. But yeah, that's it guys. Take care. I hope you enjoyed today's session. I hope you learned something new today. And stay safe. Until then, bye bye. Have a great evening. Take care. See you all soon. Bye bye. Party for sure. Once you guys come down to Bangalore, pakka. Everyone is gonna get a party. Pakka, 100%. 100%. I'm gonna make Maggie for all of you guys. We'll have a Maggie party for sure. Yeah, how many of you guys would like to come? Maggie party. You want my Maggie? My Maggie people? The classic masala. Classic masala, huh? Kanjus itself. I'm not even going for the all right. I'll get you guys noodles. Chill. I won't make Maggie. I'll buy Chinese noodles. Huh? Happy now? No more conjusi, no. Anyways, guys, once you come down to Bangalore, let me know. We'll all meet up. So until then, guys, bye for now. Take care of yourselves. Stay safe. Good night. Have a great evening. I'll catch you guys soon. Bye. Enjoy, guys. Like, share, subscribe. Don't forget. Bye.